In this lesson, we will learn to conduct a short circuit analysis in Etap. And I have my single line diagram already opened up for me. So in order to conduct the short circuit analysis, I will have to hover over to the mode toolbar and select the short circuit analysis mode over here. So I have already selected this over here, and on the right side we have the short circuit analysis options over here. So let me click on the three-phase short circuit analysis, and this is the ANSI C37 standard. So after clicking on this, you will get this error over here, because in order to conduct a short circuit analysis, you will have to fault any of the buses. So in order to fault any of the buses, I will have to click on the bus like this over here and select on fault, or I can go to the edit study case option over here and choose the bus I want to fault, and I will click on OK. So now the bus turns into red color, which indicates that this bus is fault. And next, when I will run the three-phase short circuit analysis, now we have this value over here, that is 8.9 kilo amps, and we also have some values alongside our single line diagram. So let me go to the display options over here, and I will click on show units, and I will click on OK. So these are the fault current contributed by each branch over here. So the voltage drops at this bus to 93.329 kilovolt, and over here to 96.295 kilovolt, and this is the fault current. And in order to get the fault level, we will have to use the pre-fault voltage and the post-fault current. So here the pre-fault voltage is 11 kV, so we will have to multiply the 11 kV with that of 8.9 kilo amps to get the fault level. And below this we have the single phase short circuit, and over here we have this option, which is very reliable way of running a short circuit analysis, because over here we have three-phase fault, line to ground fault, double line to ground fault, and is simulated for half cycle. So I'm using a 60 Hz system, so half cycle means about 8 milliseconds. So let us conduct this study over here. So I have already faulted my bus 3. So when I click this on over here, these values are populated alongside my single line diagram. So this is about 8.94 kilo amps at 84.9 degrees. So in order to better understand what we are looking at, I will go to this report generator over here. So let me select the complete over here and generate a report from this. So the short circuit analysis shows the number of buses, number of branches, number of machines. So let us look at another report. Okay, here we have the short circuit report, and here we have pre-fault voltage is already selected at 11 kV voltage. So the three-phase fault is as shown, and the line to ground fault is also as shown. And over here, let me see, the bus voltage becomes 0, and the symmetric RMS value of current is 8.9 kilo amps. And the line to ground fault, here we have the A phase, which is faulted. This is single line to ground fault, and the symmetrical values of the current, unsymmetrical values of current I say, because current here is 9.3 kilo amps, and the zero sequence current is also 9.37 kilo amps. And looking from the bus, we have the impedance calculated with a 100 MVA base value. And clicking on the summary, we will generate the summary over here. And here also we have the 3-phase fault, the line to ground fault. So the 3-phase fault is 8.94 kilo amps, and the line to ground fault is 9.379 kilo amps. Line to line fault is 7.764, and line to ground, which is the double line to ground, is 9.226 kilo amps. So every value is in kilo amps. And over here we have this short circuit analysis conducted for 4 cycles, and here also we have this conducted for about 30 cycles. And the other 2 options below here are for arc flash analysis, which we will study later in this course. So this is how you conduct a short circuit analysis in ETAP. See you in the next lesson.